Hello everybody, this is Mr. Storm and this is part 5 of our gravity game tutorial. It may not seem like we've done a lot already, but honestly, once we get the script written in this video, once we finish writing the script, it is going to go a lot faster and you'll be able to scale as much as you want at as many levels as you want. Pretty much just from what we've done already. The script is going to handle the entire game. So that's pretty nice. All right, so let's look at our script. Now, one thing I noticed, notice how this is blue and this is not blue. I was like, why is that not blue? And everything else is good. It recognizes it. It's looking like this is trying to treat this like a custom method. And I noticed it's because I spelled collision wrong. And now it works. Now it'll recognize. So that's a good thing. I was looking at that kind of confused, and then I figured it out. So anyway, so that's good. So make sure you spell on collision enter 2D properly. All right. So first of all, I'm going to go ahead and handle this player movement and the jumping and the animations, because that's going to be the bulkiest part of our script. Believe it or not, that's going to be the hardest part to implement. And we've already done a lot of this already. So first of all, as like we've done before, I want to create a new speed variable. So a public float, call it speed, and set it equal to, we'll just go 30. It's a good default. Okay, so we have our speed variable. Now inside of our fixed update, let's go ahead and start doing our player movement in fixed update. So we want to get, we want to float h, and that's going to be our input dot get axis raw, and that's going to be my horizontal axis, and then we are going to get component, and it's going to be rigid body 2D, and it is going to be the velocity of that rigid body. We're going to set it to vector 2 dot right and times h times speed. Okay, so at this point our movement should be good. So let me go ahead and attach that script to Unity, jump back into Unity, hit play, and see if I can move my character, which I can. All right, good. Oh, hey, it's trying to, ooh. Hey, look at that. I didn't constrain my rotations on my player prefab, so now he fell over like a big old dummy. All right, let's do that. It's best if you find problems or things that you forgot to do while you're testing. It's best just to go fix those right away. So let's go to my rigid body, go to my constraints, and I will freeze my rotation. Okay, perfect. I'm going to save everything too, just so I don't forget to do it later. All right, so now we have our movement down. Movement looks good. The next thing we want to do is we want to jump. So let's go ahead and get into the jump. And what we're going to do is we're going to basically just check for a key press. We're going to say if input dot get key down, and we're going to say key code is space. Then what we want to do is get component, rigid body 2D, and boom, boom, boom. And we're actually going to change the gravity scale. Okay, the gravity scale. Remember, we set that gravity scale to something that was pretty extreme. Set it to like 150. What we want to do is reverse that. So take that 150 and turn it into negative 150. So the way we can do that is, if you remember, I don't know, third grade math, you can turn a positive number into a negative number by timesing it by -1. That's all we need to do. So times equals -1. That essentially means that we're going to take the gravity scale. It's going to be equal to gravity scale times equal 1, or times -1. So we're basically just completely reversing the gravity scale there. And let's test that out, make sure that works. So attach that to Unity and go back in and let's play it. Okay, hit space and he jumps up and sticks to the top. But that's not ideal because I want him to actually rotate. I want the sprite to rotate. So it's working, but we need to add some more stuff to it. So let's go back to here, and let's say we do that, but then let's also transform.rotate, and we're going to rotate 0 on the X, and we'll do 180 on the Y and 180 on the Z. That way it'll rotate us all the way around, and it'll look pretty cool. Let's attach that and test it, make sure that works. So, hey, look at that. So now we have player movement. Now, the problem is, and it's going to be kind of... So we have a problem, though. And it's not really easy to see here, so because this level's so small. But let's... yeah, anyway. I was going to create a new section of the level and show you, but it doesn't really matter. Basically what's happening now, when I play the game, I can push space anytime I want. So I can, while I'm attached to the ground, I can push space and it jumps, and that's great. That's what we want. But let's say, actually it is better if I just show you. Let's get rid of this guy. Let's hide him. Get rid of him completely. Turn that off. Okay, this is going to be weird. So notice I can hit the space bar whenever I want, and it will rotate him, right? I don't want that, because if I'm dropping down a long corridor, I don't want to be able to just keep flipping in midair. I only want to flip. Let's turn that back on. I only want to flip when I'm touching the ground, okay? So there's not really a super easy way to do this. So usually whenever there's no method that Unity has to handle it, we just kind of have to write our own method. So I'm going to write my own method. I'm actually going to write it down here below my fixed update. And I'm going to call this grounded check. Okay, so... And let's check to see, what do we want to call this? Let's call it, first of all, it's going to be a public bool. And because I want to just check to see if it's grounded, it's true. If it's not, it's false. So I'm going to call this is grounded. And inside of the is grounded method, I want to, let's see, let's think about this math a little bit. Let's see. I'm going to want to check to see the bounds of my collider. So I want to get the collider bounds, and then I'm going to want to check the range of the bounds of my collider, figure out where the center of the bounds are. I'm going to do a ray cast, and if I hit something below me, then I'll say it's grounded. All right, here's what I'm going to do. I'm going to write out this method. I'm going to try to explain what I'm doing while I'm going, but this is kind of a little more advanced than what you're probably used to. That's okay. That's fine. Sometimes it's better just to see something happening, because you might absorb some of it. For later. So, all right, so what I'm doing now is I'm creating a new bounds object, not really object, but a new bounds variable. And I'm storing inside of that variable the bounds of the 2D box collider on my character. And then I'm going to create a new float, and I'm going to call it range, and it's going to be set to the bounds dot extents dot y. times 1 point, let's do 2f. Basically, that's just setting the range of my bounds, basically checking to see how far my bounds are on the y-axis. And then vector 2, create a new vector 2 called v, and bounds dot center minus transform dot up times range. Now again, please don't get freaked out by this guy. It's again, this is a little bit of raycast hit. We'll do 2D, call that hit, and we're going to physics 2D dot line cast v bounds dot center. So basically what I'm doing there is I'm creating a ray. A ray is basically just an invisible line. And I'm creating it from the center of my bounds, and I'm making it go down. So it's going to go down from the center of my character, and it's going to keep going down for about 1.2 game units. And then it's going to return hit.collider.game object does not equal game object. Basically what I've done there is I've said I'm going to check to see if I've collided with anything. If I have collided with something, I'm going to make sure if that thing is a game object, then I'm going to return false, because this is a is not game object. If it isn't a game object, this whole statement will return true. All right. Again, do not freak out if this doesn't make any sense to you. This is a pretty good is-grounded method, though. So if you're making a game where you need to check to see if your character is on the ground, this is a pretty good is-grounded method you can use for really anything. Honestly, this is kind of scalable, and this will allow you to put this into any game you want. But now I have my is-grounded method written. So now what do we need to do with it? Well, up here, we already have our jump, and we have if we push space. What we can do is we can also just add this is grounded to it. So now it'll only let me jump if I push space and is grounded returns as true. Okay. Again, that's a lot. I get it. Let me attach that and test that and make sure it works. We'll zoom out, and let's turn off my level again so my guy can float. And he's not really going anywhere. That's fine. Let's bring him. Oh. Let's grab my character. Where's my player? There he is. Let's drag him all the way up and then hit play. So notice he wasn't able to jump anymore. Let's turn our level back on. And we'll bring our player back down into the level. And drop him in there. And we'll try it again. And he still can jump because we're seeing that is grounded is selected. So perfect. All right. So the is grounded method is working. All right, our player movement is working well. Now all we need to do is set the animations for our character. Let's go to our animator really quick. Let's remind ourselves what we've done. We have idle right, going to run left, going to run right, run left, blah, blah, blah. All of this is set to this one parameter, this direction X. So all we need to do is write a line of code that says, hey, send direction X to the animator. So what we need to do is get component, and I'm going to get the animator, and I want to set integer, okay, and the integer I'm going to set is DirectX, and it's going to be I'm going to pass it in the h. Now, because this is an integer, and h, if you remember, h is a float. I actually have to cast it as an integer to send it to the DirectX integer. But that will allow me to like actually change my animations as we go. So let me go back to Unity really quickly and make sure that works. Let's go to our scene. Let's play. So now you can see we're actually changing. He's running. And it still works up there as well. Okay, so our animations are working. Our character movement is working. We're colliding with things like we're supposed to. Okay, good. All right, we have a lot of work already done on this game. Okay, back to the script. Let's take a look at what else we need to handle. Pretty much all this stuff is good. Now we just need to handle our collisions, it looks like. Let's do our checkpoint first. Make sure our checkpoint works. Actually, let's collide with it. Yeah, let's do checkpoint. All right, so first of all, up here I need to check for a position. I need to figure out how to store my position, my player's position. So let's do, this is actually pretty easy. We can just create a new transform, and we'll call this check. That works. So now I have this transform variable called check, and we're going to use it down here in this onTriggerEnterToD method. So let's figure out our checkpoints. How do we check to see if we collided with a checkpoint? Well, what we can do is we can just check the name. So if col.name, so if the name of the object we collided with is equal to checkpoint, then what we do is we set the check variable to be equal to the col.transform. Basically, whenever we run into it, then we change this transform variable. We set that transform position to be the same position as that checkpoint. That's, believe it or not, all we really have to do, because then all we have to do is call the value of that transform check whenever we run into a spike. So let's do that, actually. Let's do spikes, because these are kind of related. Let's do spikes. So this is going to be an on-collision enter 2D. This is kind of a big one, because what we need to do is check if the thing we collided with, col.collider.name equals v. So if we ran into a spike, then I want to transform dot rotation. Basically, I want to reset my rotation because I might be upside down when I hit a spike, and I don't want to start the level again upside down. So I want to transform rotation, and what I'm going to do is do quaternion dot identity. Oh, not quaternion, it's quaternion. Quaternion dot identity, and it's a lowercase I. Most things in Unity you can pretty much figure out what they are just by looking at them. Basically what this is just the standard rotation. Like, it just basically sets your rotation or whatever it is. It's dumb. You'll see it a lot when you deal with rotation. Let's see, get component, rigid body, 2D, dot gravity scale, because I want to reset my gravity scale back to what it was. I'm going to, actually it's not as, let's think about it. This is going to be a little bit rough. I want an absolute, because the gravity scale is always 150, but it's either 150 or negative 150. So I want to set it to the absolute value of 150, essentially making it positive 150. So here's what I can do. Math, and you guys know what I'm talking about, right? This is just simple math stuff. I want the absolute value of a number, meaning the positive version of that number. Math.abs, so the absolute value of get component, rigid body, 2D, dot gravity scale. Basically just set the gravity scale. Why is this not? Yeah, it is. It's value. Yeah, that's valid. This is a valid thing. Why is this not? Okay, that's weird. That should actually work. I don't know why that's not working. Let's if cold.collider, all that should work. I'm actually gonna see what the debug gives me on that. Was not valid in the given context. Get component. All right. Tell you what I'm gonna do. Transform.rotation, is that still good? Quaternion identity. All right. Here's what I'm gonna do. I'm gonna go ahead and cut. No. Yeah, I'm going to cut this video. I'm going to troubleshoot what this is, and then I'll come back with a part 2 of the coding so we can finish up the rest of the programming and testing and everything else. I'm going to just delete this statement, and I will troubleshoot, and I will show you what I've done in the next video. So basically, we've got a lot of stuff already done. Let's finish up the rest of it in the next video. So thank you very much for paying attention. I will see you next time. Goodbye.